What's going on, everyone? This is JD from Engine Squared. Today we are going to be doing a tutorial for parametric modeling of a clear span single bay shop. This will be very common for small size shops, typically used for starting operations. We're going to be using this for our mini factory concept, so we thought, hey, let's make a tutorial at the same time. It's a Saturday night. We're staying out of trouble. We're gonna do some Onshape parametric modeling here, and it'll be a very scalable concept that can apply to other types of parametric models. So we'll go ahead and start with a sketch on the top plane, and how we're gonna start this one is we're gonna use the corner rectangle feature. We want to stay in the positive X and positive Y in reference to the origin. So we'll place a point somewhere to the right and above that origin point, the positive X and Y. And we'll just make a rectangle similar to this. It can be any size. And we'll create offset dimensions from the origin to the rectangle. So we'll just put these blank placeholder uh, dimensions, and then we'll open the variable tab on the right side, and we will start with our X and Y dimensions for uh, inside to inside walls of the shop. So let's go with X here. We'll do capital X and then Y, and we will also do wall thickness, wall underscore thickness. So we're gonna go for this one with 10-inch walls. So we'll put 10 right there. Your units might be in millimeters, so you'll have to do the equivalent there. You can type in this value in millimeters. For example, 250 lowercase mm. That'll give me close to 10 inches. So I'm gonna have it back at 10 inches there. And then for the length of the shop, let's go with approximately, uh, we're going to use the Y coordinate. Let's go with 900 inches. And then for the width, let's do 350 inches. Pulling out my calculator, that will equate to about 29 feet width, and for the length, we got about 75 feet. So we can adjust those later, that's no problem. Now that we have those variables defined in the variable table, we're going to go ahead and swap them here. So for these guys, we'll do wall thickness. That's just a double click on the dimension, and then you start typing the variable name, and you can see it pops up here. So you can either click it or hit enter. So now, no matter what we change the wall thickness to, this model will adjust. So if we have a 6-inch wall, a 4-inch wall, that will adjust over here fairly quickly. So we'll go back to 10 inches. And then to constrain this and lock this in, we're going to have to put the dimensions for the length and width. So we'll go with the length here, and then the width here. So here for the length, we got Y. We'll enter that. For the width, we got X. So we'll enter that here. Now it's nice and adjusted to our shop dimensions. So we'll close the variable table. We'll get outside of the sketch, so we'll accept that sketch. And for now, we're not going to rename these, but once you develop your own methodology for doing these parametric models, you can rename the sketches. Our next step will be creating a plane. So we're going to reference the top plane over here. We just click that right there. We can throw a dimension such as 16 feet for now. You can see that plane goes up here. We will add another variable in the variable table called Z, which will represent the height of the shop. For this one, we'll do 14 feet, just so we can pick something different than the 16. I'm going to move this variable up right here, and then I'll double click the plane again and add this Z dimension. So now we can go change this to 7 feet. You can see the plane goes down. We're going to bring this up to 16 feet. So that's what we'll start with right there. The next step we're going to do is, there's a lot of ways to do this and to start this up, but we're just going to go with what I think is the best way to start off with, and we can take it from there. We can do some adjustments so down the road, but we're gonna next start with the walls. So the nice thing about Onshape is we can use the thin extrude feature. So if we open extrude, we can go to thin, and then we can select these outer lines for our first sketch. If we zoom in, we can see there is a depth, which is the vertical, and a thickness, which is the horizontal. And if we flip, you can see it goes to either side of the line. Same with the depth. So what we're going to do is we are going to use the wall thickness for the thickness. And you can see this goes right up to the origin here. So now, no matter what we change the wall thickness to, all of this will update parametrically. The depth, we will change it for now to the Z dimension, but later we will offset this based on our structural depths, if necessary. So now we have the walls for our shop. We can click accept. There's ways to split this up as well. We can use the split feature. For now, we're not going to do that. We're going to keep it simple, but we can go through that in the future for a more advanced tutorial. Right now, we're going to keep this at LOD 100 or something similar for the most part. I like to unhide these sketches because we'll use them as a reference eventually. So for now, I'm also going to hide this, but I will rename this to walls. Let's call it perimeter wall because it's one piece in the model. So the next step we're going to do here is the columns. These will be the perimeter columns. Some shops might have this, some shops might not, but we're going to do it anyways. So we're going to create a new sketch on the top plane, and we will start with the columns here. So we want to make sure not to constrain this to anything. So we're going to pick this point. There's no orange lines, which shows that it won't be constrained to anything. It'll be fully unconstrained. We can add a size for this. So let's say size column Y, then size column X. So this represents the size in the Y direction and the size in the X direction. So we can add some placeholder dimensions here. We don't want to enter this when there's no dimension defined there. So for now, we'll go with 12 inches in the Y, and we can do, let's say, 12 inches in the X direction as well. Maybe let's do 14 inches. So now we can go ahead and change these. So size CX, size CY. Maybe we can do, let's do something a bit bigger here for the Y. Let's go 24. Let's go 16 for the X. So the center point will be a framing reference for the roof, and then we'll make another variable for column offset, which will be the offset of the column protruding inside the shop. So we will just carefully drag this inside the shop a little bit, and we will make this for now 2 inches. And then we will take this dimension here and rename this to column offset. So this is around the center at the moment. We want to bring this away from the center, but make sure there's no orange lines so we're not constraining it to anything. And this seems okay. We can grab these points here from the previous sketch and project them. Then we can select them again and change these to construction lines. When we do this, we want to hide that first sketch. It seems these ones did not get changed, so we'll reselect them, redo it there. Now, oh, this one too here, not quite sure why that happened, but now we will make some solid center reference points. So we can see that square pop up there. We'll see the next one here, and we'll hit escape. That's using the line feature. We will also make these ones construction lines. And just in case, we can put an intersection point there if we ever need to use it for a rotation down the road. So now we just need to define our center, our offset from the center for the first column line. So we're going to go with whatever this dimension is, which is 450 divided by 2 or 3. So let's create this dimension from the center point. So we know this is y. So if we do y divided by 3, so that will be a bit too much. Let's go y divided by 2, and then we will put that in brackets and further divide that by 3. So that should give us what we're after. And we're just going to leave that one for now because the way we're going to do this is going to involve copies of some parts. So I believe we can leave that one the way it is for now. We will X out of that. We'll go ahead and unhide the perimeter wall. We can do another extrude for sketch 2 in its entirety because we're going to leave that the exact way it is. We're going to go back to the solid extrude feature though, not to, we'll reselect that, not to the thin extrude because this will be a solid column. For depth, we will do Z for now. We don't want to use the add because this will add it to the wall solid. We're going to use the new feature. We will click accept there. We'll go back and unhide that sketch. We'll leave the first sketch hidden because we have the reference lines projected. One other thing we'll do is drag these parameters back up. We will also create a sketch plane on that new plane that we created, and we'll hide the parts and select all of these reference points to project. We'll do a right select for, well, that might not work. We will just grab that manually. We'll hit project right here. Then we'll grab this in its entirety and make this construction line reference. We'll accept. Now we'll unhide the parts again. So one other thing we will do is grab this spot in the variable table, and we will make a parameter for copying the number of columns across the shop. So this one we're going to call it number of columns. We're going to make this a number, and we're going to have this driven as a function of the length of the shop. So we'll try that for now. We'll do the length here divided by the column spacing, which we established was, let's just leave that blank for now. If we go back to sketch 2, so we should have actually made this one a variable. So let's do that right now. And this will be a good example to show how we can do a modification without screwing up the order of the model. So we'll make this parameter called column SPC for column space. We'll copy the math that we already did into this box right here, and that'll give us the same 150 driven by the formula. And we can actually drag this to go above in the order, so that's a good thing to have, just to make sure the model follows the right sequence. And so then we can rename this column space. We will click accept there. So number of columns can be driven by the length of the shop divided by column space. So that will be 6 columns total in the long direction based on this spacing, which is a little bit more than what I was imagining for this shop. We can change this to be divided by 2 because we're only dealing with half the length of the shop. So that'll bring us to 3. And then we don't want the perimeter column in the corner for now. So we will do -1 over here. So this logic will be for if you want to make different, if you want the number of columns to change in your parametric model. In this tutorial, we're going to stick with just 2 columns, but we'll leave that set up for a future tutorial where we show how you could increase the number of columns and not just stick to the same amount. This one, we're going to be looking at parametric adjustments within a small range of dimensions, so we'll leave that as is for now. And then we're going to do a linear pattern now. For direction, we are going to use a solid reference line that will not change from the earliest part of the model. In this case, I like to use the planes because those will never go away. Alternatively, we could use the sketch one long line, but plane is a better reference in this case. So over here, we will enter column space, and it's set up in the right direction here. Instance count will be number of columns. So that's just to show you that how this can be scaled up for future more complex models. We will be making some adjustments here, so we're probably going to come back to this to make it nice and symmetric. So anyways, for now, we're going to accept that. We will also use the mirror feature here. And grab these columns. You know, we don't actually have a mirror plane, but we could use this select mate connector feature, and you can see the axis is pointing in the direction we want, so that will give us what we want there. We're going to use a new part mirror. We don't want to add those to the wall again. So we will accept that for now, and then we will use mirror again and grab these columns and use that nice center reference point with the mate connector. So we can see that came in to be pretty useful for us. And we'll also go new there. So now you can see the spacing between these columns and the end is even, but the middle one, we doubled it up. So we're gonna go back and adjust this. So what can we do here? Our target will be, you know, we might actually need to create a center offset parameter and then a column spacing parameter. So that center offset will be linked to the column spacing parameter. So I think that's the best way to tackle this one. So we'll go ahead and create column spacing center. We will drag this up here, and we will grab that reference and divide it by 2. So we will actually delete the equal sign here. That will do it for us. You can see that's right there in the tree. So we'll go back here and change this to column space center. So that's good. Now we will adjust the actual spacing value here. So maybe we can go to 2 instead of 3. So that seemed to mess up a reference because we deleted um, missing part of linear pattern 1. You know, that should not have disappeared. Yeah, I'm really not quite sure why that one disappeared, because we still have that center point reference there, so that's a bit strange. Let's just redo these. Not quite sure what's going on there. Okay, well I think I know the issue. So that's the reason. Our number of columns changed. That's why that changed. So we'll go back. We'll go back and leave this the way it is. So we will change this -1 here. We'll get rid of that. That should do it for us. $225. What if we change this back? Let's redefine this variable. Pull out my calculator, do some quick math here. Let's not divide this by 2, so we can, let's just say this will be 5 spaces. So we'll take the entire y dimension and use 5 spaces. That should do it for us. So this is a decimal. We will round this up so that we don't get that issue. We'll delete those because we already did the outside brackets there. Now we achieved what we want, which is even center spacing between these columns. So you can see here we have a dimension of 180, and then from there to here we have 168. That's exactly what we're looking for this concept. Now we will do the removes. So we'll grab the Boolean feature and subtract. We will keep the tools. We will select the columns as the tools and the wall 3D part as the target. Click OK. So first off, let's select these columns and let's make these, name them column. you can see the previously named perimeter walls got split and kept their name there, so that's good. So for now, let's hide the 3D and work on the roof. And we'll do something similar to what we did with the columns. So we'll grab a new sketch on the roof plane and we will reference the previous roof sketch that we already did. So let's grab all of these again just to be safe. We'll leave that original projection untampered. Construction line. Now we'll hide that one. So this will be the main beam. We'll actually grab this here and mirror it. So we'll use that middle line as a mirror line. And we will grab the center point of that inner column protrusion. That will actually be our main beam for our structure. And we're going to follow the same spacing that we did for the columns to make this simple, but we will add one more dimension for main beam depth. So we'll make this one 20 inches for now. And another dimension we can add for the beam while we're in the sketch is the width. So we'll do main beam width. So we'll make this one 6 inches for now. We can just create a reference line here because this will be copied for our framing. We'll make this a construction line and this will be main beam width divided by 2 because it will be mirrored across that line. So we'll accept that for now. We'll go back for missing anything. We'll unhide the 3D and we're going to go back and use the thin feature once again for this beam. So we'll select that beam line that we created. This time we're going to flip the depth to go downwards and we're going to make this the main beam depth. And then the thickness placeholder will be the main beam width. And we will make this symmetric. Oops, not this one here. I guess we will have to use this feature right here. Main beam width. We will divide that by 2. We will go back up here and divide this by 2. So that'll give us our total 6 inches. So all these things will, this is just for concept purposes. Like this will really depend on what your structure is, whether it's concrete columns, wood columns, steel columns, concrete beams, steel trusses, wood trusses. Like, you can adjust these parameters for whatever your actual shop's design is. And this really, the purpose of this for now is just for having a neat background for manufacturing simulations. So we're going to go back to the sketch and just add one more thing here. So we're going to do a similar thing that we did for the columns for the secondary beams. So let's add secondary beam depth. Do depth first, follow the same order. Then width. And then we will do secondary beam spacing, secondary beam spacing center. And that should, let's do secondary beam number of secondary beams. We'll change this to number. So let's think of what dimension we would want for the secondary beam. For now, we can go with 12 inches by 4 inches. So if we expand this to see all the parameter names, let's do 12 inches for depth and 4 inches for width. We'll go back to the spacing in a little bit here. So first of all, let's mirror these lines just to get some nice references. Well, we can do that. That's one way to do it. Let's see if we can make it work first with just driven by the shop dimensions, because that will leave it to be scalable for future purposes. So we'll grab a line here and make sure it's not constrained to anything. This perpendicular constraint is okay. For the spacing, let's follow the same logic we did for the column spacing. So instead of y, we'll use x divided by 5. So that will give us about 70 inches. And yeah, I think I'm okay with that for now. The center spacing will be that divided by 2. And then we'll copy this formula here. We'll actually copy this whole thing and just replace y with x. And we'll replace column spacing with secondary beam space. So that gives us 3 over here. If I check my reference model, I believe for now we just want 2. So let's just see what happens if we delete this round. .5. Trying to think how we would fix this. For now, for this one, let's just do a -1. Sometimes you don't want to hold up your model just because something is not working out. So we will do round. We'll put that -1 just to get it to where we want to be. And once we scale the parametric model, we'll be able to tell why this one's rounding up while the other one's rounding down. There is a feature to correct where it rounds as well. There's few ways to deal with it. For here, I believe it just rounded down, it seems. Let's test that out quickly here. Yeah, it seems like it rounded down by default there, so that's just luck of the draw. To make this more consistent, so we just did Control Z there. There are features in, let's just do a test parameter here. So there's a unit here, which I believe it forces you to round it in a certain direction. So let's see if that will work if we do it here, just to make it consistent for future purposes. So we can add all of this under one container. We can add one here. That should do it. So now if we delete that -1, this goes to 3. So we'll bring that -1 back there. And let's see if we do the same thing here. Will it give us 3 by default instead of 2? Seems not to do that. Yeah, anyways, we'll just leave it as is right now to be somewhat consistent with the formulas, but uh that's something we could probably submit a feature request for in Onshape and see if we can play with that rounding value. So anyways, and yeah, by the way, Onshape's really good at getting back to those feature requests. Extremely impressive customer service when it comes to that. There's a few feature requests we got implemented, so they're uh, they're really good with that. They definitely take them very seriously if you clearly show what needs to be done. It's not surprising to see, if you have a really good idea, it's not surprising to see it live within 3 months, even sooner than that in some cases. So that's something that's really good about Onshape, among other things. So we'll go ahead and create this center space over here. And then the length of this, we will actually just make this the column spacing, because it equates to the same length as that minus the main beam width. Let's actually just redo this one. I think that will be the better option here. Let's redo that one. So we'll do this again. we'll add the secondary beam, center spacing, and then we'll make this cleaner. So column spacing minus main beam width. There we go. So let's unhide the sketch. Let's bring these parameters back up so we can always reference them. And we'll go ahead and create this secondary beam with the thin extrude feature. So once again, we'll flip the depth here, and we'll use secondary beam depth. We'll go in new. Then for thickness, we're going to do secondary beam width divided by 2. We can just copy that, paste it here. You can see that clash there. We'll get rid of that with the Boolean. So let's go ahead and for now, we'll create a linear pattern here. We'll use the front plane as a reference, and we can use the column spacing here to make that work. I believe that is what we'll go with for now. So number of column. And you know, this, like right now we have 2 for number of columns and 2 for number of secondary beam. I mean, these really, you got to plan this out properly. We're just kind of winging it here, but you can make it so that it's the total number of building columns. In this case, it's 1, 2, 3, 4, 5, 6, 7, 8, and have that 2 as a resultant to get plugged into the linear pattern. Like it can get really, really complex, and we'll get into that in the future. But for now, we just want to show the features about how to get a simple model set up here. So we will accept this, and then for now, let's just mirror them because we're not looking at any crazy parameter changes here. We're going to use the mate connector here to do the mirror. So this will mirror the columns right down the middle. And then let me think about why this did not work out. One thing we can do here is just shift this. We can shift this by main beam width divided by 2. I don't like why that's set up that way, but we'll just run with it for now. So now we will use a linear pattern for this. So we'll use the right plane to reference, and we will use the secondary beam spacing parameter. You know, for this one, I think we should just leave these all at 2. Uh, this model specifically in its current state is not going to be scalable for uh, changing the number of columns and beam lines in a efficient way. So it is scalable. It just needs a bit of rework and some thinking as to what parameters you want to use. You also got to relink the linear patterns and the Booleans, which is not that much work compared to doing a model from scratch. But we're actually going to go back to all these linear patterns and just change these to you know what? Let's keep the parameter there, but we'll change the actual number here to 2 instead of the formula driven approach. So just to keep this on the simpler side. Main beam follows the column setup, so we're not going to touch that. We'll reopen this linear pattern and we will add a second direction and reference the front plane. So here we'll actually use the column spacing and we will add number of columns plus 1 to make sure we get the end there. If we click centered, it will copy that onto both sides. So we just knocked out a lot of things in that one linear pattern right there. I wonder if we can even get another thing. Yeah. Yeah, we could we we could probably get a bit more of that, but I'm not going to look into that right now. Um, let's just select this here and we're going to do a nice simple mirror for these elements. So we'll select the mate connector. Looks like we missed a couple. Think we're okay with that. Now for the fun part, we will do the garage. So we'll create a new sketch. We'll try to rip through this one quickly. We can just reference the, which sketch is this? Let's just see, that's sketch 2, which is, that is a projection sketch. So let's reset this view here. So let's just grab that and we're going to use an arbitrary dimension here, like 6 feet, just to make sure we cover the extrude volume. And we'll put a placeholder of 10 feet here now. So let's do garage width, garage height. So for this one, we'll do 12 feet, and the height will also be 12 feet. So we'll add garage width parameter there, garage offset. Let's do 3 feet. So that will be the offset from the interior here. And before we do that, let's jump to these right here and just rename them. So I accidentally grabbed a secondary beam there. So that will be main beam, and then just click those one by one. Shift select. We'll call these secondary beam. Then another thing is we'll select all of these because we're not really going to use these for takeoffs or anything. So we'll click exclude from all BOMs. We'll bring these garage parameters to the front. And we will do a solid extrude here with remove. So we're going to select sketch 5 in its entirety and use the garage height parameter, flip it, merge with all in case that part gets split later. We know it's not clashing with anything or interfering with anything really. So we'll accept that. Another thing we can add here is a door opening. So let's do that as well. We'll make that sketch 6. So we'll go ahead with the same logic here. And we'll actually drive this to be, we'll use that same 6-foot remove, and we will drive this to be constrained to the garage opening because we don't want to have a clash there. So door width, we're not even going to have a door width parameter. We'll just go with door height, and we'll just put 6 feet plus 8 inches. We can do 7 feet just to account for whatever build up. We can do door offset. So that will be 2 feet. We'll add that here, door offset. Door width, we'll just make it 40 inches. And yeah, that should cover us there for extrude, we will extrude from the sketch 6. We'll do a remove, merge with all. We'll select door height here, and we'll flip this around just like we did for the garage. Now we can play with this 6 feet, and honestly, even at this stage, we can play around with this model quite a bit. Like, well, not so much, but that can actually be, just to make this a bit better. If we bring that back up to 14 feet, garage height can be z minus 2 feet. So we avoid that problem that you just saw there. So now if we go back and do that, that moves down with it. So we don't have that issue anymore. Let's go 18 feet here. Now we have too big of a garage. There's many ways to have this. Like, by default, I'd probably have something like this and then manually adjust it at the end to suit whatever you want to model. Uh, Again, if you're making a lot of these models, it really makes sense to set them up this way. You can make a lot of different like simulation backgrounds and that sort of thing. So yeah, we'll leave it like this until the end. So then we'll see what to do. So for the front, yeah, we'll make a sketch at the front. We'll unhide all of these here, and we can copy these points right here and project them. We will hide the 3D and start by creating some corner rectangles. We'll keep this really simple. We can add door handles and stuff in the future. For now, we're gonna keep it really simple. So this one will be for the door. We'll keep the door and the garage separate. So we'll just fill that in with door height, and then we'll create a new sketch on the front plane for the garage. And that will be you can project these here, and for this one we're going to just make a rectangle, and I'll show you why. A short rectangle here. Show you why in a second. We can go garage height, and we're at 192 inches right now. It's about 16 feet. And we're gonna have to be careful with this one because we it might mess up the spacing if the dimensions aren't super convenient. So we'll go garage height divided by a new parameter, which will do number of garage panels. This will be a function of the garage height. So we'll do garage height we'll do another parameter here, garage panel height. We'll bring this before we put 41 inches arbitrarily. We'll just do 24 inches. Then this one will be garage height divided by garage panel height. So I'll give us 8 panels to meet the full envelope of the garage. So if we make this 36 inches, that becomes 5.33, which gives us an issue. So we got to be kind of careful what we select here. Yeah, I think 24 is a safe bet. So we'll accept that for now. We'll unhide this. We'll just make a simple door right here. So that will be sketch 7. We'll go the other way. New solid extrude. The door thickness, like we'll just make it 3 inches. Make sure that's new, not add. And then this one here we'll do a little feature for. So this garage panel will also make it like, I don't know, we'll make it 2 inches. We'll make that new. I just like to give this one some definition, so let's go with 4 inches. Let's give it some definition. Make sure that's new, and then we'll hide everything except for the garage panel, which will be part 42 in this case. We'll hide these sketches too, as we're not going to need them. I'd like to add some chamfers on this one just to give it a little bit of definition for further render. So the chamfer will be the 4 inches divided by 4. So just to give it a little feature here. And the door, we can leave it as is. Both of these, we will offset them inside just for visual effect by the wall. Let's do wall thickness divided by wall thickness divided by 1 inch. So this will just always guarantee a 1 inch offset if it's working the way that I thought it would. There we go. Alternatively, we could just put 1 inch over there, but we might want to multiply this in the future where we just go back and change this this parameter. So I don't know, we could do like 0.5 inches here. We could do 2 inches. So now it's 2. There's many things like, well, maybe we'll just leave it like this for now. So just to give it a little bit of an effect. So we'll unhide all of our stuff here and let's name this garage panel, name this door, and we can select both of these and also exclude them from the BOM. Then this one here, we will grab and pattern. So we'll select the top plane as the direction. The distance will be the garage panel height, and the instance count will be number of garage panels. That'll bring us straight to the top here. That's a pretty high garage for this size of shop. Perhaps we can change this. What did we go with for beam depth? Yeah, maybe we go 24 inches for our beam depth, and then something we could do here is, let's see if we measure from the bottom of that beam to the top of the garage. It's 0 in the Z direction, and we can end up changing this to garage height. We can do minus beam main beam depth 2 times. Let's go minus main beam depth for now. We'll leave it like that for now. So if we, let's say we go to 16 feet here, so that'll automatically update our setup here. So 14 feet gets rid of one garage panel. Yeah, I'd say we leave it like this for now. You could add another 24 inches and make it minus 4 feet. Like there's a lot of things we can do. For the setup I'd like to leave it like this. So that's what we'll do for now. The last thing we're gonna do here, obviously you can mirror these. We can mirror them. We can do that pretty quickly here if we go back to our sketches. We can project this line, and so this should actually just work right away. Yep, and then so we already had that's what happens when you link to the sketch instead of linking to some specific lines or areas in a sketch. Uh, that's one of the kind of hidden secrets for parametric modeling and Onshape is knowing when to reference a sketch and when to reference part of a sketch, depending on what you want to do. So this mirror, we will add it. Let's see how we can intelligently do this, because if you don't do it super intelligently, you miss more links. So I'm actually glad we got to show this in this tutorial, like showing some of these like rework things, and we do have some other recordings that don't quite make the cut that show those, like how to modify uh, changes going back in this tree and making sure everything's linked properly. If you'd like to see some of that, by all means, let us know in the comments. We can post those on a separate link or something. So we don't want to mirror all of these because the number changes. Like what we want to do is mirror the bottom one only, and we'll use this non-changing reference as the mirror plane. Go new here. So we got that nice symmetry right there. And now we'll bring this to before we added this linear pattern. So we'll drag this up the tree, and now we'll go back in this state of the model and select this right here. So now we can update all this, and both ends will update, both counts will update. I'm not going to bother renaming these extra parts here. Those are all the garage panels. So yeah, now is the fun part where we get to test this model. Uh, we can add the slab and things like that. I mean, I can go ahead and do that. See, these beams are not connected on the ends. That's something we can fix too, like 3 inches. So yeah, let's just you might find yourself in this situation where you're making touch-ups on your parametric model. Again, you should automate for 90% of the situation, and these little things, like depending on your scope, it's not really going to affect much. It's not too hard to do them uh, manually. So let's do main beam width divided by 2. That should take us nice and flush to the end there. I'll copy that. I use a thicken feature here and add, so we're not creating any new solids there. Thicken is a lot nicer to use than extrude, even add extrude in some situations, like especially in this situation, it's a lot nicer to use. So the merge scope is fine. Those 4 parts. So now we have 177 inches for those beams. 174 for these beams. I'm good with that, and that's in this state right here. So let's do the final touch that just gets this ready for a render in a parametric model. Like I'm sure you can uh, drop some skins on this. Like you could put wood skins or concrete skins. Uh, Maybe steel would be a little bit difficult with this cube setup, but I mean you can use different features. You can replace these lines with the frame feature, and maybe we can do another tutorial on that, like how to turn this into steel structure. So for now, we'll just cap this with some flat extrudes. So we'll select the top plane here, and we'll grab these lines. We could even just honestly, instead of, for the sake of not making too many sketches, just go back to sketch 1 and extrude off of that. So we're just gonna make this by default 10 inches slab, just as a placeholder. And we'll leave this sticking out from the bottom. I mean, in reality, this structure will go to a foundation or it might be part of the slab, however it was designed. We're not going to worry about that right now. Like uh we're just focused on the inside really and how this looks in a render, bringing it into Render Studio or something like Unity. So we'll go with that there. We'll rename this to floor. And we will, yeah, let's make another one. We'll make this one pretty thin. So we'll go sketch and then we will straight up project sketch one up to here, and we can make this a construction line. Actually, just thought of a different idea. We'll hide this and we'll create a rectangle on the outside that lines up. In this case, it'll work out. We'll just put the wall thickness here. That is over constrained now, so we'll delete this. That shouldn't cause us a problem in this this model, so we'll go with extrude sketch 9, and we'll just make this a default of 1.5 inches. We could do 3 inches, like really whatever the roof thickness will be for that. That will be a new extrude as well. So now is the fun part, for real. We'll start selecting some colors. So let's just not forget to exclude this from BOM. And let's select the roof, floor. What else? Yeah, roof and floor for now. We'll do edit appearance. We'll make them bright white. The garage panels and doors, we'll make those bright white as well. That's fine. The perimeter walls, let's make those, let's see. Let's make those white too, why not? Then columns can be, let's go with that medium kind of gray. Now we'll get a look on the inside here. So we're using the SpaceMouse Enterprise. That was given to us by 3D Connection. Appreciate that. So we'll pan around the inside of this model. This looks pretty nice, actually. Really good for a simulation. I like the idea of keeping this just white and black for now. I actually like that. Gives it more of a neutral look in the background, and maybe the simulation features can have more color, like the equipment models and stuff like that. So I'll say I'll stick with this theme for now. You can change this to whatever you want, obviously. So let's go with the same gray that we used for the columns, or maybe a shade or two lighter. Yeah, let's do that. I think I'm good with that. Let's go back and select the perimeter walls, and we'll make these transparent. We'll go to 35% here. Same with the roof. We'll make that 35%. So now we can see the internals of this whole thing. So now it's time to play around with the parameters and see if this all works or if something gets broken. Uh, so we messed around with the height a little bit already, so let's go with the length. Instead of 900 inches, let's do 700 inches. So we can see everything adjusted there, the column spacing, beam spacing, all the positions of the garage panels and door and offset elements. That's pretty nice and satisfying to see. I believe we'll have some issues with this width because we're if this dimension exceeds the width, then obviously we're gonna have some things that are broken. But let's see where we can push it to. So 300, that brings the door, 300 inches brings the door right up to the end. So we got kind of lucky there. We'd have to bring this door offset down to something like 3 feet. And honestly, that looks really nice. Like this is working pretty nicely, I would say. Uh, Column offset, let's go 6 inches. You can see that moved inside, and it pushes all the beams, adjusts all the beam lengths. Let's go 10. So now we kind of have a notch with the wall instead of it sticking out of the wall. So you can see if we hide the roof, you can see this is like a notched part now, which is, I mean, for our modeling purposes, it's fine, but to combat that, we'd have to go with the column size modification in the X direction. So if we made this 24 inches, that would bring us back to having the separate wall parts, as you can see here by highlighting it. No, that's really cool. If we go with 20 feet, let's see what that does. Okay, so that worked. I mean, we have a huge garage there, but another option for the garage is really just leaving it as its own separate parameter that's not linked to other parameters. So uh, logically, it's nice to have the top of the garage like not to exceed the beam depth. So, but the deepest beam, obviously. But yeah, no, I'm good with how this is right now. Let's see if we go longer and see the problem with going longer with this setup is you you don't want to go too long with this spacing because then you just have too little columns, and you'd realistically you'd probably add another line or two or three or four of columns to meet that length and structure. We don't want to spread this structure out too thin. Uh, in this case, we're going over that 900 inches we previously did, so we Probably want to go with some deeper beams. Again, you have to check with whatever engineer is responsible for that. But now we got 48 inches for the beam depth. You can see our garage went down as well, and our secondary beam depth, like let's say 24 inches. So see now those are updated here. So um, that's a limitation of this more like simple style parametric model. But yeah, if we go on the inside, let's toggle off the transparency here and make some rapid adjustments. So we'll pick the bottom left corner here close to the origin so we can get right at the action and see all the changes. Um, so let's change this to 1200 so we can see how that all adjusts. The width 400. So that looks like it's working pretty well, honestly. This case, you probably want to drop a column there, probably want to do something about that, but let's go 15 feet for the door offset. Garage width, maybe we go with a bigger garage, like 24 feet. Now we can go down in our door offset, maybe 7 feet, comes back into place. So you can see in that case, the door would come out of the building, and we don't want that, so we'll go back to 7 feet here. So yeah, you can see there's quite a few options here to make a bunch of different shop layouts, a parametric model in Onshape. We hope you enjoy this tutorial. We hope you learned something. Look out for more where we do some parametric equipment models, parametric factory setups, parametric robot programming. There's a lot coming. We try to make the time for these tutorials whenever we can. It's not always easy to make them, but we definitely do have big plans to keep pushing out this kind of content and building a community that really pushes Onshape to the limits, and using it for parametric modeling, parametric design, and driving process models for manufacturing simulation and that sort of a thing. It's an extremely powerful tool for us. So we really appreciate uh, all the collaborators we have that let us get to this stage and be able to do these kind of tutorials. So hit that thumbs up button, subscribe. If you made it this far in the video, thank you. We appreciate that a lot. Tell your friends, tell your boss, your partner, whoever it is, uh, to follow us and learn some parametric modeling and a bunch of different stuff in manufacturing, design, and 3D modeling. So yeah, we'll catch you on the next video. Thanks a lot.